Thank you, Charlotte. It's really good to be here, and it's great to have the opportunity to share with you this research on recovering precious metals from electronic waste. So thank you, Charlotte, for the invitation. In some respects, my own research is still at a fairly early stage, but I still think there's a lot of value that is here that people can still benefit from finding out about. My intention is to start off with a bit of context. I'll also include examples from other people's work too. And then I'll kind of dive deeper into my own practice and experience. I've called the talk Urban Gold Rush because I'm kind of arguing that the next gold rush, it's not going to be in the hills of California, and it's not even going to be in the hills of Drimmen in Scotland, where some of us are from. It's going to be in the landfill sites of urban cities. So, to give you some context, we've probably been mining gold for about 6,000 years. So far, estimates on this vary, but generally I think it's accepted that about 171,000 metric tons of gold have already been mined. What's slightly scary is about 65% of that has just been mined in the last 50 years. So when you think about just the last 50 years, 65% of it has been mined. Gold is particularly used in the electronics industry, mainly because it doesn't corrode. Silver and copper are actually better conductors of electricity. So normally you'll find on the electronic circuit boards, they're made of copper, but then there's a thin layer of gold on the top because it doesn't corrode, so it kind of protects the connections. So we tend to talk these days about urban mining. There's about £15 billion worth of gold and silver that are used every year in the electronics industry. And at the moment, certainly in the UK, it's only about 11% of the precious metals and electronic waste that is actually being recovered. So the rest of that material is ending up in landfill sites. So for the first time in human history, we've actually started to consume gold. In other words, we're using more gold than is actually being recycled and recovered. To give you a sense of scale, we need about 41 mobile phones for a gram of gold. So I think from all of us in this room, if we donated our phones, we should be able to get about a gram of gold. A standard wedding ring is probably between 1 and 2 grams of gold, so we maybe have enough for one ring for a slim finger, is what I would say. I included these are the targets and goals for sustainability that were set about 2012. And all of these things kind of related to kind of target 12, responsible consumption and production. And we're actually either in the red or the amber for achieving these. So we're really quite a long way off from achieving the sustainable development goals that have been set. There were 10-year goals that were established, so it will be interesting to see. Some of these goals relate, as you can see, to 2020 or 2030. So it'll be interesting to see just how far, what kind of progress we can make in that short time. But at the moment, we're still a long way off. From my knowledge, the three main methods of metals recovery are pyro-metallurgy, which is basically smelting, where everything is incinerated, the plastic, the metals are then they're able to separate the different metals. There's probably only about 4 or 5 centres in the world where metal can be smelted in that way from electronic waste. And at the moment, it's having to travel quite long distances to get there. There's huge issues in terms of environmental damage. The carbon dioxide that's produced kind of risks to the environment. There was another example there that doesn't seem to be coming up, but it's from a couple who work for a Dutch company called Closing the Loop. Closing the Loop is a kind of circular economy company where they're buying electronic waste from Africa and recycling the precious metals and the electronic waste. Two of their employees got engaged and decided that what they wanted to do was make their wedding rings. Let me just see if I can show you the image. Yeah. Yeah, the image just on the right shows you the wedding rings that they made. What they did was basically get all their family and friends to donate their electronic devices, their mobile phones, their tablets, and then they were able to exchange those electronic devices for the quantity of gold that would have been secured from them. So it wasn't the exact gold that came from the devices, it was a kind of exchange or an equivalent exchange. And then they had a fellow jewellery designer produce their wedding rings. So to them, both because I think they met online and they were working for Closing the Loop, they were quite keen to kind of have these wedding rings that were produced from e-waste. So if I go back to the presentation again, coming out of Closing the Loop, they've now set up a new company called Nowa, where they're claiming to be the world's first electronic waste jewellery company. You'll find in this field everybody's the world's first, which is quite entertaining. But this is, Nowa at the moment have a live Kickstarter video, and this is it.
Nowa stands for No Waste. We create jewellery by using gold and silver extracted directly from old phones. Phones our partner Closing the Loop saves from e-waste dumps in Africa. Phones play a significant role in our daily lives. They often end up here or here. However, this could also mark the beginning of something new. Research shows that about 7% of the world's total gold supply is locked inside old electronics. It only takes 40 mobile phones to extract 1 gram of gold. So your old phone contains all the ingredients needed to create sustainable jewellery. Nowa sees the beauty in waste. 70% of all our reused mobile phones eventually end up in developing countries where they cannot be recycled properly. Your purchase funds the collection and recycling of waste phones in Africa. You get a beautiful piece of jewellery and you're able to contribute to less e-waste worldwide.
So as you heard in that video, often electronic waste is shipped to other parts of the developing world. Africa, India is another big area. I've just come back from India, and there are huge kind of waste dumps that I'll talk about a bit more in a minute. And the figure I gave you at the start of how about only 11% of precious metals from e-waste is currently being recovered varies quite drastically from country to country. So in India, for example, I think it's as low as 1.5% of electronic waste, or 1.5% of the precious metals in electronic waste that is recovered. So there's big differences between countries. Going back to the main methods then, all those examples that I've shown you so far are examples of pyrometallurgy. The three kind of main methods, as you go down that list, there's varying shades of green, I would say, and the further down the list, generally the greener the process. Although again, This is, scientifically, it's an area that's often contested, but generally I think it's accepted that hydro-metallurgy, which is the method that I've been using, that uses aqueous, water-based and acidic solutions, is generally greener. The other key way that I'm not really going to talk about today is called biometallurgy, where you're using bacteria and fungus and yeasts to recover precious metals. So there's also an issue about scale here, in that with pyrometallurgy, where the work is smelted, you can do that on quite a big industrial scale. With hydrometallurgy, you can do it at a much more local level. And with biometallurgy, you can take the bacteria to the landfill site. I hope you don't ask me too many questions about biometallurgy, because it's an area, it's like magic to me. It's like, how do they do that? But it's the next big frontier, I would say, in precious metal recovery. This is me working at Edinburgh University's chemistry group. It's called the Love Group. There is actually a Professor Love. But what's unique about Edinburgh's chemistry department is they've created a new chemical compound that specifically targets gold. So I was working with the biggest flask that they had in the lab. It was a 5-litre flask. And if you look at the colour in that flask, that's going to become an issue shortly. So I was working with the biggest flask that they had. I was working at the kind of maximum capacity of the lab. We started off by taking my computer circuit board fingers, which I bought from eBay. If you're interested, you can Google in eBay computer circuit boards for gold recovery. I was able to secure for about £20 about 500 grams of computer circuit board fingers. So I started off, I chopped up the fingers first to kind of get the gold concentrated elements, and then added a hydrochloric acid solution. So they were agitated in this solution for about a week solid. And what the hydrochloric acid does is it takes all of the metals, everything. So it takes the copper, the gold, there's probably some iron and some cobalt and some other metals. We're not quite sure what, but it takes everything. So I was working as an artist in residence with the Love Chemistry group for 1 day a week for about a 6-month period. And you can see here as well, it's very colourful chemistry. It was interesting because other chemists in the lab would often come by and remark on how bright and colourful. Often chemistry is quite kind of beige solutions, apparently. So to see this kind of range of colours was quite exciting. I spent a lot of time mixing different solutions, filtering those solutions. It was probably about 15 different stages in total. Part of me, when I first started, was quite interested to see if recovering precious metals from electronic waste could be something that local jewellers could do. You know, the idea that a local jeweller would get a small chemistry set, that they could maybe recover the precious metals themselves. But I fairly quickly discovered that that really wasn't feasible because there were so many different processes involved. And I spent a lot of time shaking these flasks, kind of making sure everything was properly mixed up together and then filtering the flasks. So it was a lot of work, and you really need to be a specialist in order to conduct this. So this quote was really important to me. It's a quote from Tim Ingold, who's an anthropologist based up at Aberdeen. And he said that the maker is more of an alchemist than a chemist, because the maker is interested in looking at what materials can do rather than what they are. So I was quite keen to play and experiment with the different chemical solutions that were coming out at different stages of the metal recovery process, and just see the different effects that I could achieve, in my case, on a piece of silver. So the image on the right is some gold chloride, a fairly weak solution on a piece of fine silver, so you get this lovely kind of milky quality. These images, they're probably about 1 centimetre in height. I've obviously blown them up, but they're about 1 centimetre in height. The image on the far left is the same weak gold chloride solution, but on a piece of sterling silver. So you can see the material reacting with the kind of copper molecules. The piece in the centre is the mixed metal solution. So that was the first solution that came out of the whole process with all of the different metals included. And you can see the kind of copper needles crystallising around the outside edge. I actually decided to make a little time-lapse video of this. The chemists call this process reduction and oxidisation, but you and I would probably call it evaporation, because all I was simply doing was placing a droplet of the solution onto the metal, and it would take about 3 or 4 hours for the solution to evaporate. So with this little time-lapse video, it was over about 3.5, 4 hours, and about 750 still images, and I've condensed it down to about 45 seconds. So greatly speeded up. That little hair really annoys me as well. I assume it's a piece of the plastic that was left. So you kind of see it starting to react to the silver, and it kind of spits out things as well. I find it quite mesmerising. So that's the mixed metal solution that, like I say, included all of the metals that were first removed. So I was working with different concentrations of gold in liquid form. Again, these are about 1 centimetre in height, but you were getting some fabulous effects of the gold chloride from a really strong solution to a weak solution on silver, which I just loved. I mean, I must say I also loved the whole alchemy of the thing. You know, you start with a solid, then it transforms into a liquid, and then it transforms back again into a solid. This was a piece I made, a hand-raised silver bowl, and I used quite a strong gold chloride solution. My original intention was just to have a stripe of it at the top, and I used masking tape to block off the rest. But of course, what started to happen as I painted it onto the piece, the liquid, the solution started to seep through the masking tape. And at first I thought, oh no, this is going to be a disaster. But when I took the tape off, I actually realised I really liked it and thought that it was quite an interesting result. So consequently, I've kept the effect. I also went back to producing just a couple of simple pendants, some jewellery. So the piece on the left has a weak gold chloride solution. And the pendant on the right, when I saw the pieces of plastic that came out of the process, I actually realised they were quite gem-like in their quality. So I picked out a handful of the pieces to set in this pendant piece. So this is as far as I've got so far. I said at the beginning it's still a fairly early stage in some respects, but the next stage is now to work with the solid gold. I think it's interesting that in terms of the current kind of set of UK hallmarks, potentially we could actually have an additional mark. It wouldn't be a hallmark as such, but it would be a chain of custody mark that would guarantee that your gold has come from electronic waste. So it's something I've started to discuss with colleagues at the Edinburgh Incorporation of Goldsmiths, is the potential to have a new kind of e-mark on a piece of jewellery or a piece of silversmithing. Because, I do think that increasingly the public as well as makers are really interested in more sustainable approaches to their materials and to the work that they produce. So I think it's something that could really kind of gain traction.